Today we're going to be working with summary statistics, and those things really, it's the mean, it's the median, it's the standard deviation, anything that you can use to describe a data set. We're going to be talking about what happens when you add a constant, when you multiply by a constant, those kinds of things. So kind of some interesting details here today. The summary statistics that you use to describe a distribution usually depend on the shape of the distribution. So it's important to graph first or plot first and then look for summary statistics, because you remember what we said. If a distribution appears normal or symmetrical and mound-shaped, right? It may not exactly be normal, but as long as it's got the symmetry and is high in the middle, that means that the mean and the standard deviation are usually the best choice. If a distribution appears to be skewed, then what we said is the median and the IQR are the better choice for center and spread. So we'd like to ask you a few questions today just to get us thinking about these ideas. Suppose we wanted to know the total amount of property taxes that a local government could expect if they knew the number of houses, the mean value, and the tax rate. Well, it seems like they'd multiply the mean times the number of houses, so that would get you the average value of a house, and then multiply by the tax rate to estimate how much tax you would actually take in. So the mean would be the secret there. Number of houses times the average value per house times the tax rate would tell them that. So think about this. When a measure of center for income of a community is given, usually it's the median. They talk about the median income. Why do you think that is? Well, we've said that the median is a good choice for skewed distributions, and in many communities, folks, that's the case. Either there will be, it depends, of course, on the neighborhood. The distribution is skewed. If you're talking about Miller Road down in Flint, skewed to the high end, right? Because everybody's got lots of money down there and they got beautiful homes. If you're talking about the, I don't want to stereotype, but this is where I come from, the east side of Flint, then you're probably skewing the other way, right? Lots more people with less money. So the median income for a community is usually the better measure of center because the distribution is skewed either toward the high or toward the low end. In that vein of thinking, I'd like to have you look at this set of temperatures. These are record lows for several places around the world, and I can see there that there are places where I do not want to be. Some place where the record low is 22 below. That's probably not going to be my friend, but look at this one, the record low of 50. Folks, right now that would seem like springtime to us. Anyway, I want us to make a dot plot, and so we will, because we just want to see what's out there. Addis Ababa is at 32. That's quite a name. Perhaps right around in there somewhere. Algiers is also there, so their record low is at the freezing point. Bangkok has a record low of 50. That's Thailand. I don't know if I want to live there, but I sure would like the temperature. 14 degrees for Madrid in Spain. Nairobi, 41, so probably about in there. Brasilia, 32 degrees. So we have several at 32. And then Warsaw down here at negative 22, where I don't want to go. Alright, so if you were going to talk about the shape of this distribution, I hope you would be thinking skewed to the left, because it's definitely being dragged down by that Warsaw temperature. But what happens, folks, if we convert? Suppose we want to go the number of degrees above or below freezing that you are, and we are in Fahrenheit temps. That means that we'd have to subtract 32 from each temp. And if we subtract 32 from 32, we get 0. And there's Algiers, same. 32 from 50 is 18. So right about in there. 32 from 14, I should probably know, but I don't. 14 minus 32. Negative 18. 41 minus 32 is 9. 32 minus 32 again. And finally, 32 from 22 negative. Oh my goodness, that's negative 54 degrees. Oh, doesn't even sound pleasant at all. Hey, check this out though, folks, and this is why we did this. Do you notice the shape of this distribution is exactly the same? Adding or subtracting the same value from each data item, y'all, it changes the center, okay? Changes the mean, but not the shape or the spread. Right? They have still the same shape. They have still the same range of values. It's just that everything has been shifted down in this case by 32. So it slid the center down. It didn't change the shape or the spread, and that was subtracting the same value from each element of a data set. What do you suppose would happen if you converted each of those values to Celsius? Now, you can do this, it says, by dividing each of the differences from freezing by 1.8. So, if you think about that, 3 of those differences were 0, and 0 divided by anything is just 0. So those 3 remain the same. Then we got to think. We had a negative 54. Negative 54 divided by 1.8 is negative 30. Right, negative 18 divided by 1.8 should be 10. And we had that both positive and negative. And then we had a 9, I believe. 9 was the last of the temperature. Yeah, 9. So we need 9 divided by 1.8. And that is 5. Oh, ladies and gentlemen, that's interesting. We're on the same scale that we were a moment ago, and you can see that the range is certainly smaller. But are you still seeing the skewed to the left? Those 3 values at the center are still at the center, right? So when we divided, or you could think that's the same as multiply by the reciprocal, what happened is the basic shape, okay, the basic shape doesn't change at all. We still have the skewedness, but the spread is shrunk. Okay, the center, of course, the same, but that's what we said. Multiplying by 0 gets you 0, or dividing. In general, folks, recentering a data set, and that means adding the same value to all elements, or subtracting to all the elements. It doesn't change, folks, the shape or the spread, but it does slide the center based on the amount C that you either added or subtracted. Rescaling, that's multiplying or dividing by the same positive number D. Doesn't change the basic shape. Okay, we still retain the skewedness, we still had the peak at the center, but it stretches or shrinks the distribution, multiplying the center and the spread by D. So when we recenter, that is when we add the same thing, we change the center, but the shape and spread do not change. If we multiply each item in a data set by the same number, we don't change the shape of the data, but we stretch it or shrink it by a factor of the multiplicand, and we multiply the center by that same amount. So center and spread both get multiplied by D. Kind of interesting. Now, we've talked a little bit about this previously, but outliers. greatly affect the shape of a data set. And what we said is that the mean is considered to be sensitive to outliers. The median is usually resistant to them. Okay? It takes changes in the number of items to change the median. It takes changes in the value of items to change the mean. So the median can resist change unless you add a whole bunch more pieces of data to the set. That will stay the same. The mean fluctuates a lot based on extreme values. So we seem to have like a little hodgepodge of ideas here today that we've put into one section. Sometimes that happens. The last of these things, or one of the last that we want to talk about, are percentiles, and it says cumulative relative frequency plots. Holy moly. Well, I remember relative frequency was that percent data when you change stuff to percentages instead of data values, and cumulative just means added onto. So I'm betting that we're going to see a graph that does some kind of adding with percentages. I believe that's what we're going to see. A little bit about percentile, which is probably a term that you've heard before. The first quartile, our Q1, is the 25th percentile, since 25% of the data is at or below that point. Right? 25% of the data is trapped underneath it. The median, well, it cuts the data set up into two equal pieces, so it is the 50th percentile, since, again, 50% of the data is trapped below it. And at or below is probably the better way to say that. You can define other percentiles the same way. In general, a value is at the kth percentile if k percent of data is at or below that point. So you think about this. A situation where you'd want to be at the 99th percentile. That would mean that your data is at or above 99% of the rest of the population. I can think of several places I'd like to be at the high end of the spectrum, like perhaps IQ, I wish, but I'm not quite there. What else? Where else would you like to have almost everybody else in the whole world be below you? Some people might think income, right? We'd like to have 99% of the people in the world have less than our income, right? Although they say money doesn't buy everything. What about the other end of the spectrum? What would it mean if you were at the 3rd percentile of personal debt? So think about that, you guys. That would mean that only 3% of the population has less debt than you. That's a pretty good place to be. Actually, I'd like to be there. Unfortunately, many of us are going the other direction. Only 3% of the population would have less debt than you if you were at the 3rd. I could live with that. Only 3% of the population has less debt than you. Hey, that's worthy of a smiley. All right. The last topic today, we want to talk about a graphical display that shows cumulative percentages of data. Folks, this has got the strangest name. This is called an ogive. Ogive. Or a cumulative percentage plot. Ogive is what I'd been taught before. So as you look at this, let's read it. We're looking at SAT critical reading scores, okay? And the SAT is, of course, a college entrance exam that many people in the United States take. In our area, we're much more ACT-ish, but in the like Kansas, Midwest kind of states like that, SAT is big. When I went to a college in Illinois, I needed to take the SAT. So SAT reading scores here, and up on the edge here, percentiles. So these are percentages where, well, like this line right here, 20% of the scores would be at or below this mark. Okay? And what we are supposed to do here is estimate the quartiles and the median of the data shown. Well, the median's at the 50% mark. So 50% right there. It's got to be close to, and I'm going to just read down here. That'd be 500, like maybe 510. Just guesstimating. The 25th percentile, or the first quartile, right about in there, maybe 440. And the third quartile, that's 75th percentile, right about there. Boy, that looks like it's almost right on 600. So that ogive makes it a little bit easier to estimate the quartiles, or percentiles, if you will. It's kind of a neat graph. Again, shows cumulative percentages. So the highest it can ever go is 100. And by the time you get here at the end, all 100% of the data has been accounted for. Right? Cool little graph, the ogive. All right. I'm asking you to get out there right now, go back to the website and try that UTry. Let's get that response in there before school tomorrow. Good night.